So in extension 1 integration, you have specific areas, which are integration by substitution, as well as how to integrate sine squared x and cos squared x. So just with integration by substitution, remember to always convert back to the original variable if you're doing an indefinite integral. And if you are doing a definite integral, remember to change the limits. It's so easy to forget to do, and if you do forget to do it, you won't get the full marks. Also, in extension 1, if the question tells you to use a substitution, you have to remember to use the substitution. You must use it. And the beauty of extension 1 substitution questions is that the question will always give you the substitution. It will always tell you what to substitute. Whereas in extension 2, you might be asked to sort of come up with your own substitution. And they won't necessarily have it. So you might be able to, you'll have to sort of write down your own substitution. That's not going to happen in extension 1. However, if an integration question doesn't specify a substitution, you might also be able to do the integral by inspection without a formal substitution to save time. And that involves the use of the reverse chain rule. So here's some past extension 1 questions. So here they're like, use the substitution u equals 2x squared plus 1, or otherwise find this integral. And then here for 2004, use the substitution u equals x minus 3 to evaluate this integral. So here, in terms of the wording, they give you the substitution, but they said or otherwise, which means you don't have to use it. You're allowed to just do it by inspection with the reverse chain rule. Whereas here, they just say use it, so you must use it. So let's go and tackle these questions to sort of revise how to do integration by substitution. So here, in the 2005 HSC, where asked to use the substitution u equals 2x squared plus 1, or otherwise to find this integral. So remember, with any substitution question, when you're using it, you need to specify what you're letting u be equal to. So here it's going to be 2x squared plus 1. And then we're going to differentiate our substitution. So we can say du dx is going to be 4x. That's going to be our derivative. So therefore, we can say du is going to be 4x dx. So we can treat the derivative sort of like a fraction for the purpose of the HSC, and we can move the dx to the other side. And then what I'm going to do is I can divide by 4 on both sides. So du divided by 4 is equal to x dx. So now I have my original integral, which is x times 2x squared plus 1 to the power of 5 over 4 dx. And now I'm going to substitute all the variables and convert them all in terms of u. So we have an x dx here, which becomes a du over 4. And then we have a 2x squared plus 1, which is just u to the power of 5 over 4, like that. So this will become 1 over 4 integral of u to the power 5 over 4 du. So we can raise the power by 1. So 5 over 4 to the power of, when we add 1 to that, it will be 9 over 4. And we divide by the new power. So this will be 1 over 4 times 4 over 9 u to the power of 9 over 4, which will work out to be 1 over 9 u to the power of 9 over 4 plus c. So don't forget your plus c, because this is an indefinite integral. However, if you leave the question like this, you won't get the full marks either, because you need to remember this is just a substitution. We need to convert back to our original variable. So we said that u was 2x squared plus 1. So this thing will be 1 over 9 2x squared plus 1 to the power of 9 over 4 plus c. And that is your final answer. So yeah, that's how you would do it using the substitution. However, if you wanted to use or otherwise, if you want it to be quick and just do it by inspection, you can just use the reverse chain rule here without needing to do the formal substitution. So I'm going to redo this question, but without using the substitution this time, just to illustrate how you can do it by inspection. So our integral is x times 2x squared plus 1 to the power 5 over 4 dx. Now here's the thing. This is a function, but there's a function within the function. So when we try to integrate a function that has a function inside, we want to make sure that the derivative of the function inside is on the outside before we can integrate it, so that we can use the reverse chain rule on it. So the derivative of 2x squared plus 1 is going to be 4x. That's what the derivative is. So I want to have a 4x on the outside. The problem is I don't have a 4 on the outside. I only have an x. So in order to get a 4x on the outside, I can just multiply by 4, but I don't want to change the question. So what I'm going to do is I'm going to divide by 4 on the outside so that they balance each other out, and I'm not actually changing the question. So this is the same thing as 1 over 4 integral of 4x times 2x squared plus 1 to the power 5 over 4 dx. Like so. And now this is in the perfect form. This is in the perfect form f dash of x times f of x to the power of n, which you'll be able to see on your reference sheet. This is the reverse chain rule form where the derivative of the function inside is already on the outside. And now you can just directly integrate this whole thing. And this will be 1 over 4. I'll raise this to the power of 1. So 9 over 4 divided by 9 over 4, which is 1 over 4 times 4 over 9, 2x squared plus 1, 9 over 4, which will give me 1 over 9, 2x squared plus 1 to the power of 9 over 4 plus c. So we got the exact same answer without needing to use the substitution, so it's a bit quicker. And you can do it by inspection just using the reverse chain rule like so. Okay, so this is another question. This time we're doing integration by substitution with a definite integral. So the same steps, but remember with a definite integral, we need to change our limits this time. So we start off the same way. We're going to let u be equal to our substitution. So in this case, we said u is equal to x minus 3. So our derivative of u with respect to x is going to be just 1. So therefore, we can say du is equal to dx, like that. So now, because this is a definite integral, I'm going to change my limit. So remember to do that. So actually, I'll do it here. So change limits. So my initial limits from for x were from 3 to 4. So when x is equal to 3, and I put that in, 3 minus 3 is 0. So therefore, my lower limit for u is going to be 0. And when x equals 4 here, u is equal to 4 minus 3, which is going to be 1. So my new limits are from 0 to 1. So therefore, I can say the integral from 3 to 4 of x root x minus 3 dx is equal to the integral from 0 to 1. X is, if we rearrange this, we can say that x is equal to u plus 3. If I take the 3 to the other side, x is u plus 3. So this will be u plus 3 and root x minus 3, which we said was equal to u. And dx is going to be du. So it will be equal to integral from 0 to 1. U is the same thing. Root u is the same thing as u to the power of half. So this will be 1 plus half when I multiply u with root u. So it will be u to the power of 3 over 2 plus 3 u to the power of half, like so. And now I can integrate. So this will be u to the power of 5 over 2 over 5 over 2 plus 3 times u to the power of 3 over 2 over 3 over 2 from 0 to 1. And if I take it here, it will be equal to 2 over 5 u to the power of 5 over 2 plus 3 times 2 over 3 u to the power of 3 over 2 from 0 to 1, which is going to be 2 over 5 u to the power 5 over 2 plus 2 u to the power 3 over 2 from 0 to 1. And when I plug in the numbers, it'll be 2 over 5 plus 2 minus 0 minus 0. So therefore, my answer is going to be 2 over 5 plus 2, which works out to be 12 over 5. So therefore, that's how you would do an integration by substitution equation like that. Just remember to change your limits before you integrate.